Lead migration and lead fracture are the primary causes of lead-related therapy failure in spinal cord stimulation systems. Longitudinal lead migration is the significant and permanent movement of the lead in a direction parallel with the spine. This movement changes the location of stimulation and may reduce the effectiveness of SCS therapy. Longitudinal lead migration can be caused by the lead slipping through its anchor or the anchor pulling away from its initial location. Both of these causes may be due to increased tension resulting from stiffness on the system and typical body movements. The stiffness of the system is the amount of force required to produce a given amount of displacement. Systems with high stiffness produce greater tensile forces on the anchor compared to lower stiffness systems for the same body movement. Natural body movements can tend to cause the neurostimulator to move relative to the lead anchor, which may cause tension or slack on the lead. For instance, the total displacement between the neurostimulator and anchor is relatively low when the neurostimulator is placed in the abdomen, resulting in lower tensile forces on the lead and anchor. However, when the neurostimulator is placed in the buttocks, the relative displacement between the neurostimulator and anchor can increase dramatically due to the high degree of mobility of the lumbar spine in the sagittal plane.
Movement of the lumbar spine can increase the tension or stress upon the neurostimulation system.
As this model illustrates, flexion of the spine in the low back can significantly influence forces in the system. A lead fracture occurs when the conducting wire inside the lead insulation breaks due to stress from repeated buckling, pulling, or bending. This wire breakage prevents the lead from delivering electrical stimulation to the target tissue. For example, the tension on the paddle of a surgical paddle lead during flexion when an anchor is used can approach 1.75 pounds or more. This repeated high tensile load may result in lead fracture. Lead placement and anchoring techniques that may reduce lead fracture are described in detail in the percutaneous lead implantation and surgical lead implantation segments of this presentation.